Data modeling, the first step in designing a database, refers to the process of creating a specific data model or determining problem domain. Data model is a relatively simple representation, usually graphic, of more complex real-world data structures. Data model represents data structures and the characteristics, relations, constraints. Data structures and the characteristics, relations, constraints, transformations, and other constructs with the purpose of supporting a specific problem. Data structures and the characteristics, relations, constraints, transformations, and other constructs with the purpose of supporting a specific problem. Primary key, not unique. Foreign key, not primary key of other table. The importance of data model facilitates interaction among the designer, application programmer, and the end user, and it's a communication to different users view data differently. Data model is an abstraction. Basic building blocks. Entity is anything, a person, a place, or thing about which data are to be collected and stored, like customer. Attribute characteristic of entity, like student to student ID. Relationship describe an association among entities, like an agent can serve many customers and each customer can be served by one. One to many, many to many, and one to one. Constraint is a restriction placed on the data, important because they help to ensure data integrity, like student GPA between 0 and 4. A business rule is a brief, precise, and unambiguous description of a policy, procedure, or principle within a specific organization. Business rules help to create and enforce actions within that organization's environment. Business rules must be rendered in writing and updated to reflect any change in the organization operational environment. Properly written business rules are used to define entities, attributes, relationship, and constraint. Anytime you see relationship statement like agents of many customers and each customer, you are seeing business rules. Business rules must be easy to understand and widely disseminated to ensure that every person in the organization shares a common interpretation of rules. Like customer may generate many invoices. The main source of business rules are company managers, policymakers, department managers, and written documentation like company's procedures, standards, and operations manuals. The database designer job is to reconcile such differences and verify the results of the reconciliation to ensure that business rules are appropriate and accurate. The process of it is essential to database design. For firstly, they help to standardize the company bill of data. Second, they can be a communications tool between users and designer. Third, they allow the designer to understand the nature, role, and scope of data. Allow the designer to understand business process. Fourth, allow the designer to develop a proper relationship, participation rules, and constraints, and to create an accurate data model. A customer generate many inquiries contains two nouns and a verb. There are object of interest of the environment, and there's a generate relationship. Customer is the one side, invoice is the many side. Entity name should be descriptive of the objects in the business environment and use terminology that is familiar to user. An attribute name should also be descriptive of the data represented by the attribute. It's also good practice to prefix the name of an attribute with the name of an entity in which it occurs. For example, in customer entity, the customer credit limit may be called credit limit, and the curse indicates that the attribute is descriptive of the customer entity, while the credit limit makes it easy to recognize the data contained in the attribute. Evolution of data models. File system, BMS, BSAM, used mainly on IBM mainframe system managed records, not relationship. Hierarchy and network, IMS, ADA, BAS. Early database system, navigational access, relational, Oracle, MySQL, Miss SQL Server, conceptual simplicity, entity relationship modeling, and support for relational data model. Conceptual simplicity. Conceptual simplicity and entity relationship modeling and support for relational data modeling. Object-oriented Object-oriented Oracle 11G Objectivity. Object relational supports object data types. Star schema support for data warehousing. Web database become common. XML hybrid DBMS like Oracle 11G MySQL Server Terminal. Unstructured data support. Model supports XML documents. Hybrid DBMS as an object from front end to relational database. Unstructured data supports unstructured data support. OR model supports XML documents and hybrid DBMS as an object from end to relational database. Hierarchical models is manage large amount of data for complex manufacturing projects like Apollo rocket. Its basic logical structure is represented by upside down tree. The hierarchical structure contains labels of segment. A segment is the equivalent of a file system record type. Within the hierarchy, a high layer is perceived as the parent of the segment directly beneath it, which is called a child. Hierarchical model depicts a set one to many relationship between a parent and its children. Each parent have many children, but each child is only one parent. Network model created to represent complex data relationship more effectively than hierarchical model to improve database performance and to enforce the database standard. In the network model, the user perceives the network database as a collection of records in one-to-many relationship. However, unlike the hierarchical model, the network model allows a record to have more than one parent. While the network database model is generally not used today, the definition that emerged with network model use like the schema, which is the conceptual organization of the entire database as built by the database administrator, and the sub-schema is defined the portion of the database seen by the application programs that actually produce the desired information from the data contained within their database. Or data management language, which defines the environment in which data can be managed and to work with the data in the database. Or data management language defines the environment in which data can be managed and to work with their data in their database. And the schema data definition language enables the database administrator to define their schema component. A schema data definition language enables the database administrator to define the schema component. Network model disadvantage is as information is grow and more sophisticated database and application will require, the network model became too cumbersome. The lack of ad hoc query capability put heavy pressure on programmers to generate the code required to produce even the simplest report. And although the existing database provided limited data independence, any structural change in the database can still produce hardware in all application programs that draw data from the database, because relational model is a mathematical concept known as relation. To avoid the complexity of abstract mathematical theory, relation is as a matrix composed of intersecting rows and columns. Each row in relation is called tuple. Each column is an attribute. Row, tuple, record, column, attribute field. The relational model also describes a precise set of data manipulation constructs based on advanced mathematical concept. The relational data model is implemented through a very sophisticated relational database management system. It performs the same basic functions provided by the hierarchy and network, in addition to hosts of other functions that make the relational data model easier to understand and implement. Its ability to hide the complexities of the relational model from the user and manage all of the physical details while the user sees it as a collection of tables in which that are stored, where it can manipulate and query the data in a way that seems logical. RDBMS uses SQL to translate user queries into instructions for retrieving the requested data. RDBMS uses SQL to translate user queries into instructions for retrieving the requested data. SQL makes it possible to retrieve data with far less effort than any other database or file environment. From an end-user perspective, any SQL-based relational database application involves a user interface, a set of tables stored in the database, and the SQL engine. The end-user interface allows the end user to interact with the data by auto-generating SQL code. Each interface is a product of the software vendor's idea of meaningful interaction with the data. You can also design your own customized interface with the help of application generators that are now standard vendor database software now. A collection of tables stored is in a relational database or the data perceived to be stored in table. The table simply present the data to the end user in a way that is easy to understand. Each is independent. Rows in different tables are related by common values and common attributes. Rows in different tables are related by common values and common attributes. SQL engine largely hidden from end user executes all queries or data requests is part of the DBMS software, and the end user uses SQL to create table structures and to perform data access and table maintenance. When SQL engine processes all user requests largely behind the scenes and without the end user knowledge, so it is a declarative language that tells what must be done but not how it must be done. Entity relationship model. The graphical representation of entities and the relationship in the database structure that quickly became popular because it complemented the relational data model concept. The relational data model and ERM combined to provide the foundations of tightly structured database design, and they are normally represented in entity relationship diagram, which use graphical representation to model database component. Entities and entities represented in the ERD by a rectangle, also known as an entity box. The name of the entity or noun is written in the center of the rectangle. The entity name is generally written in capital letters and is written in singular form. Relationship describe association among data. Most relationships describe associations between two entities. When the basic data model components were introduced, three types of relationship are one-to-many, many-to-many, and one-to-one. The ER model uses the term connectivity to label the relationship type. The name of the relation is usually an active or passive verb. Relationship describes association. More data, more relationship describes association between two entities. Name of entity is returned in the center. The object-oriented model. Both data and relationship are contained in a single structure known as an object. The ODM is the basis for the object-oriented database management system. It's said to be a semantic data model because semantic indicates meaning. An object is an abstraction of a real-world entity. An object may be considered equivalent to an ER model entity. More precisely, an object represents only one occurrence of an entity. Object considered equivalent to an ER model entity. Object considered equivalent to an ER model entity represents only one occurrence of an entity. The semantic content is defined through several of the items in it. Attributes describe the properties of an object, like a person object includes the attribute name, social security number, date of birth. Objects that share similar characters that are grouped in classes. A class is a collection of similar objects which share structural attributes and behavior matters. In general sense, a class objects that share similar characters, they are grouped in class. A class is a collection of similar objects which share structural attribute and behavior matter. In a general sense, a class resembles the ER model entity set. However, a class is different from an entity set in that it contains a set of procedures known as matters. A class matter represents a real-world actions like finding a selected person's name, changing a person's name, or printing a person's address. They are equivalent of procedures in traditional programming language. Matters define object behavior. Classes are organized in a class hierarchy. The class hierarchy resembles an upside-down tree in which each class has only one parent. The customer class and the employee class share set of parent person class. Inheritance is the ability of an object within the class hierarchy to inherit the attributes and methods of the classes above. Things like customer and employee can be created as subclasses from the class person. In this case, customer and employee will inherit all attributes and methods from person. Customer and employee will inherit all attributes and methods from person. Object-oriented data models are typically depicted using Unified Modeling Language categories. Unified Modeling Language is a language based on object-oriented concepts that describe a set of diagrams and symbols that can be used to graphically model a system. UML graph diagrams are used to represent data and the relationship with larger UML object-oriented system modeling language. The object representation of the invoice includes all related objects within the same object. But note that the connectivity 1 and money indicate the relationship of the related objects to the invoice. The 1 as the customer object indicates that each invoice is related to only one customer. The M next to the line object indicates that each invoice contains many lines. The UML class diagram uses 3 separate object classes and 2 relationships to represent this simple invoicing problem. Note the relationship connectivity are represented by 1, 1, 0, 1, etc. and that the relationship are named in both ends to represent the different roles that the object play in the relationship. EM model also uses 3 separate entities and 2 relationships to represent this simple invoice problem. Facing the demand to support more complex data representation, the model main vendors evolved the model further and created a standard relationship data model. The ARDM gave birth to a new generation of relational database supporting object-oriented features like objects and constructor data methods, extensible data type based on clusters and inheritance. That's why DBMS based on the ERDM is often described as an object relational database management system. When organizations integrated the business model with the internet, they realized the potential of internet to access and exchange critical business information. They used XML data, soon realized there was a need to manage the large amount of unstructured data like word processing documents. So XML database emerged to manage unstructured data within a native XML format and added support for XML-based documents within the relational data structure. Hybrid DBMS is emerging that retain the advantage of the relational model and at the same time provide programmers with the object-oriented view of the underlying data. These types of database preserve the performance characteristics of relational model and semantically rich programmatic support of the object-oriented model. Object-oriented view. SQL servers like Microsoft SQL Data Service on its Azure Service Platform are becoming critical component of relational database vendors' internet service strategy. This cloud-based that is remotely processed internet-based data service make it possible for companies of any size to store the data in relational database without incurring expensive hardware, software, and personal costs while having access to high-end database features like failover backup, high transaction rates. And companies can use a pay-as-you-go system based primarily on the storage and bandwidth utilization of the feature use. Costs. Having access to high-end data features and make it possible for companies to store data in relational database. Make it possible for companies to store data in relational data service. Make it possible for companies to store data in relational database. Make it possible for companies to store data in relational database. Hierarchy is first difficult to represent many-to-many relationships. Second, structural labor dependent. Third, no ad hoc queries. And fourth, a SAS path predefined. Relational first, conceptual simplicity. Second, provides ad hoc query and third set-oriented access. And entity is first easy to understand, second limited to conceptual modeling. And then for object-oriented, there's first more semantic in data model, second support for complex objects, and third inheritance for behavior. Fifth, unstructured data and sixth, UML data exchange. The ANSRSPARC architecture defines three levels of data abstraction: external, conceptual, and internal. The external model is the end-user view of the data environment. Because data being modeled, ER diagrams will be used to represent external views. A specific representation of an external view is known as an external schema. To illustrate the external model, conceptual model, internal model, and physical model. Degree of abstraction from network hierarchy low, relational medium, object-oriented ER high, object-oriented hardware independent, software independent, relational hardware independent, software dependent, network hierarchy both hardware and software dependent. A professor may teach many classes and each class taught by one professor, so one-to-many relationship. A class may enroll many students and each student may enroll in many classes, so many to many. Advantage of external model. It makes it easy to identify specific data required to support each business unit operation. It makes the designer job easy by providing feedback about the model's accuracy. Specifically, the model can be checked to ensure that it supports all process as defined by the external model, as well as all operational requirements and constraints. It helps to ensure security constraints in the database design. Managing an entire database is more difficult when each business unit works with only a subset of data. It makes application programs development much simpler. The conceptual model represents a global view of the entire database as viewed by the entire organization. Thus, the conceptual model integrates all external views, entity relationship constraints, and process into a single global view of the data enterprise. Also known as the conceptual schema, is the basis for the identification and high-level description of domain data objects. Used to graphically represent the ERD is used to graphically represent the conceptual schema. Advantage is firstly it provides a relatively easily understood bird's-eye view of data environment, and secondly independent of both software and hardware. Software independence means that the model does not depend on the DBMS software used to implement the model. Hardware independence means that the model does not depend on the hardware used in the implementation of the model. The internal model is the representation of the database as seen by the DBMS. In other words, the internal model requires the designer to match the conceptual model's characteristics and constraints to those of the selected implementation model. An internal schema depicts a specific representation of an internal model using the database construct supported by the chosen database. Because the internal model depends on a specific database software, is said to be software dependent. Internal model requires designer to match conceptual model characteristics and constraints to those of the selected implementation model. Therefore, a change in the DBMS software requires that the internal model be changed to fit the characteristics and requirements of the implementation database model. A change in the DBMS software requires that the internal model be changed to fit the characteristics and requirements of the implementation database model. However, the internal model is still hardware independent because it is unaffected by the choice of the computer on which the software is installed. Therefore, a change in storage device or even a change in operating system will not affect the internal model. The physical model operates at the lowest level of abstraction, describing the way data are saved on storage media like disks or tapes. The physical model is dependent on the DBMS methods of processing files and types of hardware storage device supported by the operating system. When you can change the physical model without affecting the internal model, you have physical independence. A change in storage device matters, and even change in operating system will not affect the internal model. Physical model operates at lowest level of abstraction. Dependent external high degree of abstraction. Conceptual internal medium degree of abstraction, physical low. External focus and user builds independent of hardware and software. Conceptual focus global build of data independent of hardware and software. Internal focus on specific database model independent of hardware, and physical focus on storage and access model independent of neither hardware nor software. A data model is an abstraction of a compressed real-world data environment. Database designers use data model to communicate with application programmers and end users. Basic data modeling components, entity, attribute, relationship constraint. Business rules are used to identify and define basic modeling components with their specific real environment. Hierarchy and network data models were early data models that are no longer used, but concepts found in current data model. Hierarchical model depicts a set of one-to-many relationship between a parent and its children. Network model is set to represent one-to-many relationship between record types. The relational model is the current database implementation standard. In the relational model, the end user perceives the data as being stored in table. Tables are related to each other by means of common values in common attributes. Tables are related to each other by means of common values in common attributes. Tables are related to each other by means of common values in common attributes. The entity relationship model is a popular graphical tool for data modeling that complements the relational model. The EM model allows database designer to visually present different views of data as seen by database designer, programmers, and end users, and to integrate the data into a common framework. EM model allows database designers to visually present different views of data as seen by database designer, programmers, and end users, and to integrate the data into a common framework. The object-oriented data model uses objects as the basic modeling structure. Object-oriented data model uses objects as the basic modeling structure, and object resembles an entity in that it includes the facts it defines. But an entity and object also includes information about relationship between the facts as well as relationship with other objects, thus giving its data more meaning. The relational model has adopted many object-oriented extensions to become the extended relational data model. Object relational database management system were developed to implement the ERDM. And at this part, the ORDM is largely used in specialized engineering and scientific applications, while the ERDM is primarily related to business applications. Although the most likely future scenarios an increasing merger of ORDM and ERDM technology, both are overshadowed by the need to develop internet access strategy for database. Usually, all data models are depicted using unified modeling language class diagram. Data modeling requirements are a function of different data builds, global versus local, and the level of data abstraction. Data modeling requirements are a function of different data builds, global versus local, and level of data abstraction. The ANSI-SPARC American National Standard Institute Standards Pioneer Requirement Committee describes three levels of data abstraction, which is external, conceptual, and internal. Also, fourth level, physical level. Lowest level of abstraction is concerned exclusively with physical storage methods.